this video, we are going to study about the instrument function generator. We will study that what is a function generator, what is the use of function generator, its block diagram, construction and working. So let us start with our topic. Function generator, we can say in our basic language that it is a type of instrument which is used to generate the different types of waveforms like sinusoidal waveform, like triangular waveform, rectangular waveform, square waveform. So different types of waveforms which are having different frequencies, they can be generated with the help of this instrument function generator. So we can define function generator as a signal source because it is generating the various types of signals. So it is a type of a signal source which has the capability of producing different types of waveforms as its output signals. Now the different types of waveforms or the most common waveforms which are generated by this function generator are sine waves, rectangular waves and triangular waves, sawtooth wave. So these types of waveforms are most commonly produced by the function generators. Now, because the function generator, it is generating these waveforms, so these waveforms should have will have some frequencies. So the frequencies of these signals, they can be adjusted from few hertz to several kilohertz. So we can say that the function generator, it is going to produce the waveforms in the range from a fraction of hertz to several hundred kilohertz. So in this range it can produce the different waveforms. Now the function generators, they are considered as the most versatile instrument in the electrical and electronics laboratory because the waveforms produced by the function generators, they have applications in different areas. So because these waveforms, they are to be used for various types of application or for a number of application, that is why the function generator, they are considered as the most versatile and common instrument found in the laboratories. That these waveforms, they are used for different types of applications. There are also some of the features in function generator which make them it a versatile instrument. So let us study these features of function generator. The first feature of the function generator is that The first feature of the function generator is that the various waveforms which are produced by the function generator, they are available at the same time. Means if at the same time we want that a sinusoidal waveform and a triangular waveform will be available, should be available from the function generator, then the function generator, it has that feature that it can provide the various types of outputs at the same time. So for like for different applications, there are two applications. In one application we want a sinusoidal wave, and in another application we want a square wave. So at the same time the function generator is capable of providing the two types of outputs. So that is the feature of the function generator which makes it a versatile instrument. So if different if the generator has generated two different signals, so these signals can be used for two different applications also. Let us see some example of this feature, that how the various outputs of the generator can be used for different applications. The first example is the case that we are providing a square wave and a sawtooth wave. The function generator is providing the square wave and a sawtooth wave at the same time. It is used to drive the horizontal deflection amplifier of an oscilloscope, where we are getting the visual display on the screen for the measurements. So simultaneously a square wave and a sawtooth wave is provided by the function generator, which are used for the two different applications. So here you can see that the square wave is used for the linearity measurements in an audio system, whereas sawtooth wave is used to drive the horizontal deflection amplifier of an oscilloscope, which is giving a visual display for the measurements. Okay. Another example of this feature is the generation of a triangular wave and a sine wave. Okay. So triangular wave and sine wave of equal frequencies, they can be produced by the function generator. So when a triangular wave and a sine wave of equal frequencies are produced by the function generator, such that the zero crossing of both the waves are made to occur at the same time. Means at the same time both the waves, they are crossing the 0 point. This will be the case when, suppose this is a triangular wave and sinusoidal wave having the same frequency. Both are generated by the function generator. So the zero crossing means when the signals, they are passing this 0 point, it is occurring at the same time. So in that case a linearly varying waveform is available, and this waveform, it can be started at the point of zero phase of the sine wave. Now this type of waveforms, they can be used for measuring the phase difference between the two signals. So this is the application where the function generator is generating two types of waveforms, and they are used for the different applications. So this was the special feature in the function generator. Another special feature of function generator is the capability of function generator of phase locking an external signal source. So this is also another feature of the function generator, that it has the capability of phase locking to an external signal source. Let us see that how this feature is used in different examples. First example is that now we are having two function generators, and both these function generators are phase locked with each other. So these two function generator, they will be providing us the two output signals. So as these function generators are phase locked, so the two output signals, we can vary the phase between these two signals by a fixed amount. Okay, like if we want that the two signals, they will be having a phase difference of pi by 2 pi or 3 pi by 2, so we can vary this phase difference by, because the two function generators, they are phase locked with each other. So the two output signals, they can also be displaced in phase by one adjustable amount. If we are varying one signal by pi by 2 or by some amount, we are changing its phase, so that same amount of phase will be produced in the phase change will be produced in the second output signal also. Okay, second example is that so in the second case, one function generator, it is phase locked to a harmonic of the sine wave of another function generator. One function generator is providing an output signal, another function generator, it is providing a sine wave. So the harmonic of that sine wave will be phase locked with the first function generator. Now in that case, by the adjustment of the phase and the amplitude of the harmonic, so if we are adjusting the phase and the amplitude of that harmonic sine wave, almost any waveform may be produced. Any waveform means that any waveform which is the summation of the fundamental frequency which is generated by the one function generator and the harmonic which is generated by the another function generator. So the any waveform which is the combination, or which is the summation of the fundamental sine wave and the harmonic sine wave, they can be produced. So that is the use of this second feature of the function generator. Another example is that so when a function generator is phase locked to an accurate frequency standard, and all its output waveform will have the same frequency, stability and accuracy as that of the standard. So when we are phase locking with a function generator with a standard frequency source, so all the characteristics of that standard frequency source will come into the output waveforms of the function generator. So these are the three uses of this special feature of function generator, that it has the phase locking capability to an external signal source. Whenever an external signal source, whatever quality that signal source will have, that quality will come into the output signals of the function generator when the two generators are phase locked with each other. So these were the two features of the function generator. Now let us come to the block diagram of the function generator. If we see the block diagram, it will be So this is the block diagram of a function generator. The various components are here. We are having a frequency control network. Then we are having two constant current supply sources, 1 and 2. Then we are having an integrator, capacitor, a voltage comparator multivibrator is there, a resistance diode shaping circuit, two output amplifiers are there, and as the function generator it gives us the waveforms, different types of waveforms. So here we are having three types of waveforms: a square waveform, a triangular waveform, and a sinusoidal waveform. So this is the block diagram of the function generator. Let's study the functions of each of the blocks in this diagram and also study its working. Now, as we have said that the function generator, it is capable of producing different waveforms in the frequency range from minute fractions of hertz to several hundred kilohertz. So how this frequency is controlled in this block diagram? In this block diagram, we are having the integrator. Okay, we are having an integrator. So the frequency is controlled by the magnitude of this current which is driving the indicator. Okay, so we can say that the frequency is controlled by the magnitude of the current that drives the integrator. So as in this block diagram we are having two current supply sources. So both of these current supply sources, they are uh, going to vary the frequency of the uh, output signal. Okay, now this function generator, it is providing different types of waveforms. Three waveforms are there: sinusoidal, triangular, and square wave. Where we are having the symbol, this is for sinusoidal wave, triangular we are having this symbol, and for square wave we are having this symbol. Now these three waveforms, they are produced in the frequency range of 0.01 hertz to 100 kilohertz. Okay, so in this frequency range we can produce the three different types of waveforms. Now here in this block diagram, we are having a frequency control network. So this frequency control network, it is going to control the frequency, and here on the front panel of the function generator, we are having a knob which is called the frequency control, and by varying this or moving this knob, we can change the frequency of these output waveforms. So here we are having a frequency control network which is governed by the dial which is present on the front panel of the instrument. Also here we are having an external frequency control also. So this external frequency control can also govern this frequency control network. So first part is the frequency control network in the block diagram. This frequency control network, either it is governed by the frequency dial on the front panel of the instrument, or it can be governed by an external frequency control. Now the second part is that because this frequency control network, it is providing the frequency control voltage. So this frequency control voltage coming out of this control network, it is going to regulate the two current sources. You can see we are having the supply source 1 and 2 written over here. So this upper current source, it is going to supply a constant current to this integrator, whose output voltage is going to increase linearly with the time. Whereas this lower current source, it is going to provide the voltage which is going to change the output voltage of the integrator, which is going to decrease linearly with time. So due to this upper current source, the output voltage of the integrator is increasing linearly with the time, whereas due to this the second current source, that is lower current source, the output voltage of the integrator, it is decreasing linearly with time. So the upper current source, it supplies a constant current to the integrator, whose output voltage is going to increase linearly with time. Now the magnitude of this output voltage will be E out equals to minus of 1 upon C integration I dt. Okay, this is the output voltage of the integrator due to the upper current source. Now any increase or decrease in this current, it is going to change the slope of the output voltage, because this upper current source, which is supplying a constant current to this integrator, so if there is any change in the in this current, so the slope of the output voltage of the integrator, that is also going to change. Okay, now this was due to the upper current source. Now comes the lower current source. Now the lower current source, it supplies a reverse current to the integrator. Okay, and due to this reverse current, the output voltage of the integrator, it decreases linearly with time. Okay, so if we see that due to the upper current source, the output voltage, it is increasing linearly with time, means it will be in this way. As the time is increasing, it is also increasing linearly with the time. Due to the lower current source, which is providing a reverse current, the output voltage is decreasing linearly with time. So it is going to decrease in this way. Again, it is going to increase linearly with time. So this increase in voltage will come. Again, decrease in voltage. So in this way, we are getting a triangular wave. Okay. So you can see that the output of the integrator, it is directly the triangular wave. Now for the square wave, what the voltage comparator multi-vibrator is connected here. So this, when the output voltage of this first, the upper current source, it is providing the voltage which is increasing linearly with time. Here it is increasing linearly with time. Now when the voltage, it has attained a predetermined value on the positive slope, this integrator output voltage, it is going to terminate. Okay, and this will become constant then. After that, due to this lower current source, again the decrease in voltage is going to come, and when it has come to a predetermined level on the negative slope of the output waveform, the voltage comparator, it is again going to changes its state, and it is going to switch on to the current supplies. So this voltage comparator and multi-vibrator, it is going to decide, or due to this comparator, the output waveform, which is a square wave, that is produced. So what the voltage comparator multi-vibrator does, when this upper current source is providing the current which is increasing linearly with time, so when this has come to a predetermined value, it is going to cut off the supply, and this supply will be connected to the constant current source. Again, in the negative side, if it has achieved a predetermined value, again it is going to change the state by switching on and off this switch. Okay, so with the help of this switch and voltage comparator, a square wave is produced from a triangular wave. So the comparator is going to produce a square wave which is having the same frequency as that of the output of the integrator. Now comes the sinusoidal wave. So for sinusoidal wave, we have the resistance diode shaping circuit in the block diagram, and this circuit, it is going to change the slope of the triangular wave so that it will be converted into a sinusoidal wave. So you can see that the output of the integrator is basically a triangular wave which is converted into a square wave by the comparator and into a sinusoidal wave by the resistance diode network. Okay, so in this way, the three types of waveforms which are having different frequencies, they are produced by the function generator. The shape of the waveform will be decided that which circuit is being used, and the frequency is decided by the frequency control network. So different waveforms which are having frequencies in the range from 0.01 Hertz to 100 kilohertz, they are produced by the function generator. So this was the block diagram and the working of the function generator. About the applications of the function generator, we can say that wherever we need that different types of waveforms are to be supplied in a circuit, in an electrical and electronic circuit, we can use the function generator. Now if we want to display the waveform of this function generator, if we want to see that waveform, this function generator is given as an input to the CROs, that is cathode ray oscilloscopes. So the waveform, that is either square wave, sine wave or triangular wave, they are displayed on the screen of the cathode ray oscilloscopes. So if we want to measure the frequency, that what is the frequency of these waveforms, what is the time period, amplitude, that can be done with the help of the CROs. So in conjunction or with the help of the CROs and the function generators, the signals are provided in the electronic and the electrical laboratories. So that is the main application of the function generators. So in this video, we studied that what is a function generator, what are the special features in the function generator which makes it a versatile instrument, and then we studied the block diagram and the working of the function generator. So I hope that this topic, function generator, it is now clear to you. Thank you.